Picture this, a bold new frontier, the Martian landscape stretching out as far as the eye can see. It's the dream of countless visionaries, but what if I told you that the reality of living on Mars might not live up to the hype? In this video, we're unraveling the complex web of challenges that could make Mars a less than ideal habitat. From the relentless dust storms that can engulf the entire planet to the psychological toll of being millions of miles away from Earth, we'll journey through the untold obstacles that could turn our Mars fantasy into a cautionary tale. But that's not all. Stay tuned for the unexpected factors that often get overlooked in the rush to embrace the red planet. It's a captivating exploration of why the grass may not be greener on Mars, and you won't want to miss a moment of it. From Mars rovers to the Webb telescope, exciting space discoveries are happening in our time. And now, with the Artemis 1 mission, we will begin to explore space deeper than ever before. As the NASA Artemis 1 mission paves the way for exploration of Mars, the question remains, can we live on Mars? The answer seems to be, it's possible. Many scientists consider Mars and Earth twins because of the similarities between the planets. But they aren't entirely alike like we think. Some challenges would need to be overcome before humans could start calling Mars home. We need to consider many things such as the differences between Earth and Mars, how long is a day on Mars, what are our basic survival needs, and many more.
Mars is a fascinating planet, the most like Earth of all the planets in the solar system, and may help us to understand much about the origins of life on Earth. Undoubtedly, it's a wonderful place to explore, especially with augmented reality vision. But though it was quite Earth-like in its first few 100 million years, it is not at all Earth-like now. Earth remains by far the most habitable place in our solar system. The most inhospitable places on Earth, such as Antarctica, even in the depths of winter, and at the center of the continent, are far more habitable than anywhere else in our solar system. Space colonies and the poles of the Moon are both more easily habitable than Mars, and more easy to make self-sufficient. Why is that? Stay put while we go on a cosmic journey to find out more fascinating facts about the red planet. Before we get carried away by the white-balanced, enhanced looks of the red planet, let's talk about the challenges we face on Mars. Can people live on Mars? There are 4 primary necessities for human survival. These are water, shelter, food, and oxygen. And these are all issues that we must address as we ponder, can people live on Mars? Firstly, water on Mars. Scientists have found water on Mars, but not in the same form it's found on Earth. There is some water on the surface and below, but because of the extreme cold on Mars, it is all ice. And not the ice like we experience on Earth. On Earth, ice is just water, but on Mars, with the high levels of carbon dioxide, ice contains water ice mixed with carbon dioxide ice. There is also water inside of rocks, but the lack of surface water would be a challenge for humans wanting to settle on Mars. Scientists continue to learn more about Mars, which will help them find out where we could obtain water from. Secondly, shelter on Mars. Building places to live on Mars poses a challenge. Transporting construction materials to Mars could end up being way too expensive. Homes on Mars would need to withstand radiation levels, temperature fluctuations, lack of oxygen, and other conditions on Mars. And new environments call for alternative structures. A few possibilities are that humans could live in ice igloos or below the ground surface. Also, many designers have created above-the-surface habitats that fit the necessary specifications. Food on Mars. Growing food on Mars won't look like the farms that we have on Earth. Instead, crops would need to be grown without soil, such as tank farming or aquaculture. This is where the food would be planted in nutrient-rich water and fed with artificial lights. Some scientists have discussed creating a more suitable atmosphere for growing food on Mars. That would involve adding some greenhouse gases into the Martian atmosphere to make it thicker. However, due to the enormity of that project, it's more realistic to think that humans living on Mars would rely on aquaculture. Air on Mars. Humans need oxygen to survive, and the Earth provides plenty in our atmosphere. So, one of the biggest challenges of putting people on the planet is the shortage of oxygen. The air on Mars is thinner than that on Earth. On Earth, 21% of the air is oxygen, which is what makes it the ideal place for human life. But on Mars, oxygen makes up 0.13% of the air. The majority is carbon dioxide, which is harmful to humans. NASA has been experimenting with MOXIE, an instrument that would convert carbon dioxide to oxygen on Mars. So far, this instrument on the Mars Perseverance rover has managed to successfully create oxygen from carbon dioxide. This leads the way for bigger experiments and possibilities for air on Mars. Aside from the necessities to sustain life, there are other challenges that people would face if they were to live on Mars. For example, the temperature gets very, very cold at night, below -100 degrees Fahrenheit. Mars also has dust storms, high levels of radiation, and less gravity than Earth. So, before we can start to call the red planet home, we'll need to solve these problems. Top reasons to not live on Mars. You see so many news stories about the possibility of humans colonizing Mars, and many readers may get really excited by the idea. But few of these stories mention the many drawbacks and downsides of human colonization. I thought it might help redress the balance to talk about this. 1. Length of time. The time it takes Mars to orbit the Sun is longer than it is for Earth. However, a day on Mars is about the same amount of time as it is on Earth. This is a huge bonus in scientists' minds. How long is a Mars day? Keep watching to find out more. How long is a day on Mars? One thing that attracts scientists to the idea of humans living on Mars is that it has a similar axis tilt and orbits the Sun. However, the orbit is longer than that of Earth. So exactly how long is a day on Mars? Well, because Mars is further from the Sun, it takes the planet 687 days to orbit it. Compared to the 365 days for Earth, that makes a Mars year much longer. Even with this time discrepancy, the length of a Mars day is similar to Earth. A full day's rotation on its axis takes 24 hours and 37 minutes. Or, about 40 minutes longer. Another similarity between Earth and Mars is the presence of seasons on the red planet. However, the temperature is much more extreme due to the thin atmosphere and proximity to the Sun. 2. Cold. You would agree that the center of Antarctica in winter is cold, not the best of places to set up home. Well, Mars is far colder. At the Curiosity site, which is close to the equator, typical nighttime temperatures are -70 degrees centigrade. Occasionally it drops to below -100 degrees centigrade. It is often cold enough for the carbon dioxide in the atmosphere to freeze out as dry ice. A human couldn't survive those temperatures without technology. Average temperatures on Mars are similar to Antarctica. The only reason the entire planet isn't covered in ice is because it has so little water to turn into ice, and as the atmosphere is a near vacuum, the ice sublimates into water vapor, like dry ice, and collects at the poles. It gets warm at midday, briefly, can go over 0 degrees centigrade. So it is not cold all the time, but the average temperature is similar to Antarctica, and it has these huge temperature swings of 70 degrees centigrade, sometimes more, between day and night, just about every day. Mars might not look as cold as Antarctica, because it has ice only at its poles. But that's because of the thin atmosphere. Over most of the surface, ice sublimes directly to water vapor without ever turning liquid. There is also not much water vapor. As a result, it is extremely dry near the equator, cold enough so that it would have a permanent ice cover, like Antarctica, except that it is too dry, and the atmosphere is too thin to support it. If you are just looking for new land for humans to live in, there are many uninhabited areas of Earth that could be made habitable with the levels of technology proposed for Mars. It makes much more sense to colonize Ethiopia's Danakil Depression and its landscape, or Siberia, or the Inner Hebrides of Scotland or the Arizona or Sahara deserts, or indeed the seabed, than Mars. 3. Vacuum. Yes, Mars does have an atmosphere, it's true. But it is so thin, it would count as a laboratory vacuum on Earth. For most purposes, you might as well be in space or on the moon. A human would need to put on a spacesuit to survive the low pressure, never mind the lack of oxygen. The pressure is so low, your saliva and the moisture coating the interior of your lungs would boil. The average Mars surface pressure is well below the 6% Armstrong limit, which absolutely is the limit for human survival. Average surface pressure is about 0.6% of Earth's sea level, which I'd basically 10 times worse. A leak in your spacesuit would kill you quickly. No oxygen to speak of either. The atmosphere does have some benefits, as a source of carbon dioxide, but even then, its low pressure has to be pressurized to be useful. In a space colony, then you could make carbon dioxide from the carbonaceous near-Earth asteroids. It's not that hard to find ways to make it in space if you expand your habitat, e.g. with greenhouses, and need more atmosphere. And our atmosphere is mainly nitrogen and oxygen, only 0.04% carbon dioxide, and carbon dioxide levels above 1% are hazardous to humans. The carbon dioxide on Mars has some value for making rocket fuel, using imported hydrogen as a feedstock. But again, rocket fuel in the form of water is abundant in many places, even available at the poles of the Moon, so this is not a major advantage of Mars over anywhere else. So again, that's not a major benefit over space or the Moon. 4. The "it's been done" syndrome. Okay, I know that Mars hasn't been done yet, but many explorers who want to colonize Mars have as their main motivation that it is new. They aren't interested in colonizing the Moon, because it has already been done. They just want to be the first people on a new planet. If that's your motivation, then remember, as soon as the first colonists arrive on Mars, then it will already be done. For a colony to survive, it would need massive support from Earth, billions of dollars every few years. Those of us who lived through the Apollo landings will remember how much excitement there was about the first landings, and then within just 2 or 3 years, it became boring to the public to see astronauts on the Moon, because it has been done already. Apart from occasional moments of human interest, such as the first time a golf ball was hit on the Moon, the general public lost interest totally and the news dropped to the back pages of the papers. The same would surely happen with colonists on Mars. Just as the Moon may seem boring to you now, well, same would be true of Mars after a few years. 5. Dust and dust storms. Every Martian summer, roughly every 2 Earth years, you get a higher chance of global dust storms. These can last for weeks, and the light from the sun drops by over 99%. These storms often continue for weeks, and the dust storm season happens every 2 Earth years. In dust storms like this, artificial light is needed to grow plants, solar power won't work, and the dust is also potentially hazardous for humans. And you won't see far from your habitat or if you try to travel. Though the winds are not hazardous, the dust is as fine as talcum powder or cigarette smoke, or they wouldn't be lifted at all, and the atmosphere is a near vacuum. The strongest winds would barely move an autumn leaf. As a minor point, the dust itself may be hazardous to humans. Some studies showed that moon dust may be somewhat hazardous, not as much as asbestos, but enough to be of concern. Mars dust may be similar, we don't know its constitution well yet. It also has high levels of perchlorates, and may also have traces of gypsum, both of which could be hazardous to humans if breathed in. This last issue may be addressable, however. The surface of Mars is covered in dust. However, the suit port should help prevent explorers from bringing it into the habitat. Normally, dust gets onto the suits and then would be brought into the habitat. Apollo astronauts found that dust got everywhere. It could also risk clogging up machinery. But with the suit port idea, the suit is never brought into the habitat, so reducing this risk. Not much you can do about the darkness during the dust storms though, except artificial lighting and just sitting them out. 6. Contamination. It is almost inevitable that a colony on Mars will eventually contaminate the planet with Earth microorganisms. At current levels of technology, I don't see how that can be avoided. A human is host to about 100 trillion microorganisms in 10,000 different species. A habitat would have many other microorganisms too, in the food, in the soil, other supplies, and floating in the air. Some of those may be able to reproduce on the surface, particularly lichens, and some hardy microorganisms, polyextremophiles that may be able to survive in marginal habitats of cold salty brine that may form around deliquescing salts in the morning and evening. Some of these can do just fine in human habitats but have surprising hidden capabilities to survive in extreme conditions. The rovers are sterilized to prevent contamination, humans can't be. Now, if you aren't a scientist, that might not bother you much. But back on Earth you would be known as the people who irreversibly contaminated Mars. You would probably get a fair bit of negative press for doing that, and through all the future of human history would probably be known as much as the humans who contaminated Mars as the first to colonize the planet. The contamination could also affect your water supplies. There's also the possibility that it could evolve on the surface through adaptive radiation into new forms hazard to humans, because the conditions are so different, strong UV, cosmic radiation, etc. These then could return to the habitat some years later, still retaining their abilities to survive in a human habitat, but with extra capabilities from their evolution on the surface of Mars. What it amounts to is that to contain contamination we would need to land a biohazard laboratory on Mars, with the crew and all its contents as the biohazard to be contained and kept away from the surface of Mars. We don't have the technology to do that yet at a reasonable cost. Indeed, I'm not sure it is possible at all with present-day technology when you take account of possibilities of accidents and hard landings. There is also the possibility of life already on the planet. Some scientists think there may be life on the surface even now in the harsh conditions there. If so, there is a remote possibility that it might be hazardous to humans. Could be a pathogen like Legionnaire's disease which we are not immune to. Could be that it infects other microorganisms within the habitat. Or could be an allergen for humans, e.g. when you breathe in the microorganisms into your lungs. 7. Hard to make self-sufficient. Need for parts and supplies from Earth. Yes, there are lots of resources available on Mars. But they are available in space too, mining the near-Earth objects also called NEOs. Mining on Mars will be hard to do, as hard as in space. You still need to use spacesuits because of the vacuum conditions. And however much you can make from native Mars materials, at least at present levels of technology, then many components and replacement parts will have to come from Earth. The habitats would be extremely complex technologically. Things would go wrong eventually, and you would need parts from Earth. It seems unlikely that you could really supply all the food by plants grown on Mars, and if you were able to do that, yet sometimes crop failures would surely occur, especially early on. Again, this needs food to be supplied from Earth. Medicine would be needed too, and other supplies that need high levels of technology. Spacesuits are also complex mechanisms that could fail, and that the colony would be surely unable to make, and only able to do some repairs for them. It's best to think of spacesuits as more like mini spaceships than aqualungs. A typical latest NASA spacesuit would allegedly cost about $1 billion to purchase. It requires about years of work and would take someone who had all the necessary skills about 2.5 years or more to build, given supply of all the parts and materials needed. Especially, you are totally reliant on the environment regulation of the air composition and temperature of the habitat, and again if this machinery breaks down and can't be repaired, you die. There is no way a Mars colony could be totally self-sufficient in the near future, except with some game-changing technology such as nanoscale 3D printing or self-replicating nanotechnology. 8. Boring landscape to unassisted human eyes. The landscape on Mars may seem quite stunning in some of the photos. But these have been digitally enhanced with the white balance changed, to help geologists to recognize rock types. To human eyes it is a dull reddish grey or brown. The sky is the same color too. It will be hard to distinguish different colors and everything looks much the same. You probably wouldn't get much chance to explore it directly for safety reasons and because it takes so long to put on your spacesuit. Mainly you would just see the view from your window, whatever that is. You definitely would get tired of the dull grey landscape and skies. 9. Accidents. Okay, so accidents happen. On Mars they may well be fatal if they result in damage of your spacesuit or habitat. Also, in a vacuum, you can die just because you have forgotten one step in your checklist while you put on your spacesuit, or because you get interested in what you are doing and forget to allow enough time to get back within your oxygen reserves. Or just get delayed. Example, a sprained ankle on Mars might well kill you because you then can't get back to your oxygen supply in time to top up. And if you get caught in a solar storm, that could be deadly again if you are far from the nearest shielded habitat or rover at the time. In the future we may use robots for exploring most of the time rather than humans for safety reasons, even when there are humans close by who could go. Especially for really long duration multiple day EVAs, rovers controlled by telerobotics may become the norm rather than humans. No need to carry food, oxygen or water. Able to just stop anywhere and work on something for days on end, or just spend days or weeks on a single experiment out in the open. The people operating them via telerobotics can switch from one to another, as you do with the game Civilization, doing all the interesting things, while the robots do the boring stuff. Robots do it better may well be a slogan much in use in future space settlements. 10. Mars is too small to be worth colonizing. Yes, I know the surface area of Mars is large, comparable to that of Earth. But there are several other consequences of such a small planet. Such as cosmic radiation, high levels would need to limit the amount of time you spend on or near the surface without protection from the cosmic radiation, otherwise you have an elevated chance of getting cancer. Also, low gravity. So far it's not known whether humans can remain healthy long-term in a Mars gravity. Same is true for the Moon, but is easier to return sick astronauts from the Moon to Earth. Example: if it is found that bone loss is as bad in low gravity as in zero-G, there have been many biologically surprising results for zero-G, and there may be surprises for low-G as well. The human body is complex and impossible to simulate in detail in a computer model. You can't just draw a straight line from zero-G to full G and interpolate to find the effect of low G. For all we know, it could even be worse than zero-G or better than full G in its effects on human health. Issues astronauts encounter in zero-G include bone loss. In zero-G it is about 1% per month, muscle atrophy, about 5% per week to start with, blood loss, about 22% within a few days, could be a contributing factor for heart atrophy. Many of these clear up on return to Earth. As a rule of thumb, it takes 1 day to recover for every day in orbit. But the evidence so far suggests you might not recover from bone loss completely. You can easily lose 20% of your bone mass in a long-duration spaceflight. Long-term, you can get serious vision problems too. 1/3 of astronauts returning from space have impaired vision, and in one case the impairment was permanent. We have no way to truly simulate less than 1 gram for long time periods on Earth. It might be completely safe for humans, but again it might cause long-term problems like zero-G. As well as effects on adults, it might also be, for instance, that children's bones don't grow in low gravity, or that it is impossible to give birth safely. UV radiation. It has hazardous levels of UV radiation. Again, have to be careful about exposure. Atmosphere not recycled through continental drift. This is mainly relevant for long-term prospects. On Earth, carbon dioxide, which gets captured in the seas, eventually recycles to the surface through continental drift and volcanoes. If we were somehow to find a way to introduce an atmosphere to Mars, it probably wouldn't last long in geological timescales, unless some alternative cycle can be set up. Surface area is far less than for space colonies. If you thought the surface of Mars was large, well, space habitats potentially have much more space available. So we shouldn't get too hung up on the large surface area of Mars, as it's not the only place we could colonize. Okay, all of those can be addressed: protection from cosmic radiation, centrifuge sleeping quarters, and indeed the whole habitat could be set spinning to increase the gravity felt inside, and UV radiation easy enough to protect against. The area for colonization is comparable to Earth, so only seems small in comparison to space colony potential. But it all contributes to make Mars not quite as enticing as it would seem at first. Colonizing closer to Earth first, the amounts of resources available to build space colonies just from the near-Earth objects, NEOs, is surprising. There is easily enough material in NEOs to build habitats with many square kilometers of living area, and with just about all the materials we need to make them. Longer term, space colonies have more potential for human habitation than planetary surfaces. And that is including the Earth itself. There is enough material in the asteroid belt to build colonies with the land area of 1,000 Earths. In the nearer term, the most habitable surface areas of any celestial body in the solar system outside of Earth are probably the poles of the Moon, where there are the peaks of almost eternal light that get constant year-round light. This would give near constant solar power and light for greenhouses, except during eclipses. They are also right next to the craters of eternal night, which are thought to have deposits of ice and are the coldest places in the inner solar system. So a fascinating place to explore and live, and with just about all the materials you need to build a small near to self-sufficient colony. The peaks of almost eternal light might need to be explored scientifically using rovers first to minimize contamination. For instance, maybe there are layered deposits of ice preserving a record of the history of the early solar system and the solar winds. That exploration could be done by humans too, however, by telepresence. Long term, a location close to the Earth makes for faster trade both ways, and permits space tourist visits. Shorter term, it also makes for easy assistance and backup in case of emergencies, and astronauts can, if necessary, be returned to Earth within a day or two. Also, technical assistance for near-Earth colonies can be given by experts on Earth in close to real time without the light speed delays of Mars. Solution to all of this for Mars: telepresence. So, I'm not against Mars colonization. Would be great if these problems could be solved, and maybe with some future technology they could be. Perhaps self-healing spacesuits and spaceships, able to hold in contamination even in a hard landing or accident. Perhaps some successor to the suit port that is self-cleaning and lets no air escape at all. Or we might find out things about Mars that lead us to decide that it is okay to introduce Earth microorganisms to it. But in the meantime, space colonies would seem to make much more sense than a Mars surface colony. But Mars is such an interesting place to explore, especially for scientists. With enhanced vision, the boring landscape would become interesting to look at and explore. And our mechanical rovers on Mars are so slow, experiments take months to complete, and they do in a month what a human could do probably in an hour.
So, what can we do? Well, the answer is telepresence. The technology is developing rapidly, both through the games industry and through various applications. With humans in orbit around Mars, then they could explore the surface with telepresence.